Гра-та-та-та-та, стреляй па-па-па, убегаешь от меня, смотришь мне в глаза. Гра-та-та-та-та, стреляй па-па-па, убегаешь от меня, смотришь мне в глаза. Гра-та-та-та-та, я так люблю тебя, моя бэби-мама. Тебе не нужны Гуччи, Луи, Прада. Своей простотой убила во мне года. Они попают с небес, ну и ладно.
Hi, we are going to discuss about the variation of parameters method. Given that we have a second order linear differential equation with constant coefficient and the fx is non-zero, we need to recall the homogeneous solution, and in this part we are going to discuss about what is our yp. We have four main steps in order to solve by using the variation of parameters method. First of all, we need to find out what is YH, the homogeneous solution. Then we set up YH is given by AY1 plus BY2. We want to know what is Y1 and Y2. Then we will bring to the step 3. We need to determine YP, which is given by UY1 plus VY2. Then finally, we need to combine the solution Y equals to YH plus YP. Okay, students, let's get started. Let's take a look at one example. I take this from the final examination question, semester 2, 2018-2019 from PQT 112 course. Hi, let's take a look on how to solve this problem by using the method of variation of parameter. Okay, so given that y double prime minus 3y prime minus 10y equals to 7x e 5x. So the solution that we wish to find is y, where y equals to yh plus yp. So first of all, we need to find out what is our yh. As usual, in order to find yh, we need to equate our fx to 0. So that we have this kind of equation, and then we need to transform this equation in the form of characteristic equation. Then this is our characteristic equation. And note that when we try to find b squared minus 4ac, we have greater than 0. So in our mind, it should be we have two different roots. Okay, so by factorizing this equation, the characteristic equation, so that we have two different roots here. Okay, so when we have two different roots, so the solution is AEM1x plus BEM2x, so that we end up with the YH, the homogeneous solution. So now we move on to find out the Y particular. Okay, so Y particular YP is given by UY1 plus VY2, where U and V comes from the formula of this and this one. We have negative y2 fx over aw dx, y1 fx over aw dx. So we need to integrate both u and v. And we know that y2 and y1 comes from the homogeneous solution, where actually the homogeneous solution is given by ay1 plus by2, so that next to your constants a and b are your y1 and y2. So you need to figure out what is your y1 and your y2 from your homogeneous solution, and then we plug in into the formula of u and v. And fx comes from the general equation. So what is the general equation? So general equation is given by ay double prime plus by prime plus cy equals to fx. So means that your fx is here, and then we plug in here and here, and then we have a. Okay, so a is the coefficient of your y double prime, and now we want to know what is our w. So Wronskian is given by y1, y2, and then y1 prime, y2 prime. Okay, so we cross multiply. It's just like we want to find the determinant, but this is not the determinant. So y1 times y2 prime minus y1 prime times your y2, so that we have the Wronskian. So our u is given by this formula, or we need to integrate with respect to x. Do not leave your dx here. Okay, so we just substitute the information that we have, but before that, let's try to find Wronskian. The solution just now is YH equals to AE negative 2x plus BE 5x, right? So next to your A is your y1, next to your B is your y2. So we plug in here y1 and y2 and its derivative of y1 and y2, and then this one times this one, we have 5e3x minus minus, it becomes plus 2e 3x, then we have 7e3x. So we substitute into the formula. So this is our y2, this is our fx just now, comes from the differential equation. A is the coefficient of y double prime, which is 1, and this is the information that we have from the Wronskian, and we need to integrate with respect to x. Then what we can do here is we have 5 and 5, so exponent 10x minus 3x, so we have exponent 7x. We try to simplify this integrand, okay? So 7 and 7 can be cancelled out, then what's left? So what's left? So we have 7 exponent 7x, and in order to integrate this integrand, what we need to do is it requires integration by parts, or we can apply the tabular method, which is similar to the integration by parts. So this is the column for you to differentiate, and this is the column for you to integrate. I would suggest to put the polynomial function inside your u column, because we wish to differentiate until we get 0. And then the remainder just put at your dv column, which is the part for you to integrate. So I want to put x here because x is a polynomial, so this one is e7x. So I want to differentiate x, will give me 1, okay? So integrate this one will give 1 over 7 e7x, and then we have differentiate 1, I get 0, and then this one is 1 over 49 e7x. So the cross, okay, we cross here, and then alternate sign of plus minus, then we have negative outside, okay, then we try to multiply. X times 1 over 7 e7x is 1 over 7 x e7x, okay, and then negative, positive, and then this one is positive, so that we have negative sign, so 1 over 49 e7x. So no need to plus a constant c or any constant, because we already have constant at our YH. So we just leave our U like this. Okay, so this is our U. Okay, so now we continue to find out what is our V. So we just substitute. This is our Y1. This is Y1. This is our Fx over A, and this is our W, the Wronskian, and then I try to simplify first. 7 and 7, so I can cancel out, and then e5x minus 2x, which is we can get e3x, and then we have e3x also, so that we can cancel out exponent. Okay, so what's left? So we just have to integrate x with respect to x, which gives us x square over 2, which is half x square. Okay, so we already get u and v. So we want to find out what is our solution of yp. So I just show you here. I want you to substitute all the information previously that we have obtained. What is our u? So just write down what is our u here, and then we multiply with our y1. So what is our y1 just now? You need to plug in here, and then we have v. So substitute. We need to substitute what is our v that we have obtained just now. Okay, and then we multiply with our y2. Okay, you try to simplify first the yp, and then you get the solution here. So I want you to plug in all the information and then substitute into the formula of yp, uy1 plus vy2, and then try to simplify, which is y1 you can multiply into your u as well as your y2, and then you try to simplify, then we get the yp. And finally, you must write down what is the general solution. The general solution of y is given by yh plus yp, so that we have yh is this one, and then you need to substitute what is your yp. So you will get the general solution. Why general solution? Because a and b still just unknown, and then we don't have specific values for a and b. If the initial conditions are given or boundary conditions are given, then you can substitute into your y, which is your general solution, in order to get the particular solution. Okay, so I hope that you can understand on how to solve the second order linear differential equation with constant coefficient, okay, by using the variation of parameters method. Hi, this is our second example. Find the general solution. General solution to y double prime minus 3y prime plus 2y equals to exponent x over 1 plus exponent x by using the variation of parameters method. So, before, let's see, the question does not mention to apply variation of parameters method or the undetermined coefficient method. Means that the equation just asks you to find out the general solution for this particular question. Okay, so you should know that undetermined coefficient method is failed to solve for this problem, because the undetermined coefficient method is restricted for the three cases that we have learned previously. Okay, so that we have no choice. We must apply, or we must use the variation of parameters in order to solve for this problem. Okay, but before that, let's take a look on the condition in order to apply the variation of parameters method. Okay, first of all, you must have a non-homogeneous equation. Okay, we have non-homogeneous equation because our fx is non-zero, right? Okay, and then the second condition is we must have constant coefficient of second order. So we have second order with constant coefficient because this is just a is 1, our b is -3, and our c is 2. We don't have any variables in front of our y double prime and y prime, so that we can say we have second order linear differential equation with constant coefficient, and this fx is non-zero. Okay. Okay, we know that the solution is y equals to y homogeneous plus the yp, which is the y particular. So now, okay, this yp is given by uy1 plus vy2. Okay, so in order to find the solution, we must start finding the y homogeneous first. So as usual, in order to get the y homogeneous, we must equate our fx to 0. Then we have this kind of equation. Then we need to transform this equation in the form of characteristic equation. Then we have this one. Okay, check b squared minus 4ac, and we found that we have greater than 0. So we will have two different roots here. And then when we have two different roots, so this is our YH. Okay, so we have AE M1X plus BE M2X. So this is our Y homogeneous. Then we want to find out what is our YP. Okay, now we want to find out our YP. So YP is given by UY1 plus VY2. Okay, we know that U and V are given by the formula where the formula consists of the Wronskian. Okay, the Wronskian, in order to get Wronskian, we need to determine what is our Y1 and Y2. In order to know our Y1 and Y2, we must always consider or look back what is our YH. Next to the constant A and B are our Y1 and Y2. So here, I just set up my Y1 and Y2. Then, I want to find out what is my Wronskian. So, I cross here. Okay, exponent x times 2 exponent 2x. So, I have 2e3x. So, minus this one times this one. So, I just have exponent 3x. So, I substitute all the information inside my formula of u. So, u is given by negative. So, we need to integrate y2. This is our y2, and then this is our fx. Exponent x over this one is our fx. Okay, and then over once again, a is 1, and this is our Wronskian just now. Okay, I try to simplify first. This one and this one is e3x. So e3x, and then divide by e3x, which means that you have e3x minus 3x here. Okay, so that exponent 0 becomes 1 lah. Okay, so we have 1. So we can cancel out here. Then we have 1 over 1 plus ex. So we have negative sign outside. So, in order to integrate 1 over 1 plus exponent x, let's try to apply the long division because integration by parts is fail. What else? We cannot apply the partial fraction, okay, because we don't have any polynomial function here. Okay, let's try apply the long division. So by long division, I have 1, okay, divide by 1 plus ex. So I want to cancel out 1 here. So what I need to do is I just multiply by 1. Okay, so 1 times 1 is 1. Okay, and then exponent x times 1 is exponent x. So I have this one. Then I minus here. Okay, so 1 minus 1 is 0. So 0 here, this one is 0. 0 minus exponent x is negative ex. So by using the long division, I will have 1. Okay, this one I have the remainder is minus exponent x over 1 plus exponent x. So, negative, okay. The integration of 1 over 1 plus exponent x by long division, I have integrate 1 minus ex over 1 plus ex. All these integrate with respect to x. So I will have, okay, negative outside, and then integrate, okay, integrate 1 with respect to x is x. So I have minus integrate ex over 1 plus ex. We can apply the substitution technique. Okay, by using substitution, let u equals to 1 plus ex, and this is obviously our du. Okay, so that we can conclude we have natural log 1 plus ex. So this is our u. By long division, you will get this solution. Okay, but let's try to use manipulation. You just manipulate your 1 over 1 plus exponent x. Okay, we want to integrate this. we want to integrate this one. So I just take out 1 over 1 plus EX here. Okay, so let's say I try to manipulate. Okay, so I just multiply the denominator and denominator by exponent negative x. Why I multiply by exponent negative x? So exponent negative x over exponent negative x, you can cancel out. So you just imagine that you did nothing actually, because you can cancel out, then you will get the original function back. But here I try to manipulate. Why I put exponent negative x here? Why I choose exponent negative x? This is because I want to cancel out exponent x here. So exponent negative x times exponent x, I will get 1. And then when I multiply by 1, I will get the same at my numerator. Okay, so when I try to multiply with exponent negative x, okay, at my numerator and denominator, I will have exponent negative x over 1 times e negative x is e negative x plus ex times this one, I will get 1. So what I can say is, okay, integration of this one is equivalent to integrate of this one with respect to x. Okay, so note that here you can see that this is your u, okay, and then you will have your negative negative du dx here. So you will get the solution of negative natural log e negative x plus 1 as your solution to this one. Okay, so if you try to manipulate, you will get this solution. If you try to apply the long division, you will get this solution. It doesn't matter, it's okay, you still get the same solution. But okay, if you try to apply the long division and you try to manipulate, secara zahirnya you will get different, but actually it means the same thing. Okay, so now we continue to find what is our v. So substitute all the information into our formula of v. So I have exponent, so I have here is e2x, okay, e2x divide by e3x, I will get e negative x over my denominator is this one. So here, how to integrate? So I just apply long division. I don't want to manipulate. Okay, so I just apply the long division. So we have e negative x here, okay, divide by 1 plus ex. Our target is we want to eliminate e negative x. So how to eliminate e negative x? So what we need to do is kita boleh darabkan dengan, we can multiply by e negative x. So 1 times e negative x, we will get e negative x. Okay, so we can cancel out e negative x after this. Okay, so next is ex times e negative x, I will get 1. Okay, because ex times e negative x is e to the power of 0. E0 equals to 1. So minus here. Okay, so exponent negative x minus exponent negative x is 0. So and then this one is 0. 0 minus 1 is negative 1. So I can conclude that integration of e negative x over 1 plus ex is e negative x. You just take e negative x, so we have e negative x as a single function, and then we have negative sign here, kan? So I have negative, and then I have 1 over the remainder, which is 1 plus ex. Okay, so now we can say that the integration of this one is actually equivalent to integrate of this. Okay, and note that integration of this one is just direct integration. We can get the solution, which is negative e negative x, but here you need to do something, and we believe that we already find the solution of this. okay, previously, okay, in our solution. So what we can do is we can just apply or just take the solution that you have found previously. So now we can solve for the integration. So we have integrate e negative x is negative e negative x. Then we have negative, and then take back what is the solution of 1 over 1 plus ex. Okay, so then you plug in here, so that is your v. Okay, we can reach the solution of yp by substituting what is your u here. Plug in all your u, write down your u, and then times your y1, okay, plus all your yv times your y2, and then you try to simplify by multiplying your y1 into your u and your y2 into your v. Try to simplify. You will get the simplest form of your yp. Then plug in into your solution. Y equals to yh plus yp, where your yp is given by uy1 plus vy2. So you need to write down your final general solution. So that is the idea of variation of parameters method.